Welcome to our very first homework video tutorial that I've posted on YouTube. This tutorial will be concerning the homework assignment that you received on Tuesday, April 14th and will be due on Thursday, April 16th. And the assignment would be page 12, numbers 6 through 9. Okay, now this assignment, I want to start with the big idea. And the big idea of this assignment, and much of this unit, will be about comparing different things. Okay, so comparing is our big idea here. For example, what I mean is, you'll hear math teachers a lot of the time use this very lame example, but it's very applicable here. And that example would be this one I've written here, which states 2 apples plus 3 apples, of course, is, you got it, 5 apples. However, what would happen if we tried to compare 2 different things that weren't necessarily the same? Would it be as easy? Now, of course, you already see apples and oranges. And we know apples and oranges are both fruits. We like that, okay? But what would happen if I said, hey, I give you 2 apples and 3 oranges? What do you have? Okay, of course the answer might be, I have a bunch of fruit. But could you tell me I have 5 fruit? Do you have 5 apple oranges or orange apples? Okay, it's very hard to do this. Now, if we were to convert these to being the same thing, like we do with the example of I have 5 fruits, okay, it makes things a little bit easier. Okay, so it's through this context I want to use to address the problems that I've given you for this assignment, starting with number 6. Now you'll notice I wrote number 6 with an asterisk next to it, which means it's not necessarily number 6. However, it is an extremely similar example of what it is that I would expect you to do. Okay, so looking over this, I am going to show you exactly what I expect to see on your paper and the understanding that I want you to get out of this. Okay, so let's start with number 6, which actually asks us, it says label the following numbers on the number line below. Now my favorite thing is, I give this problem to students, and the very first thing they do is just slap these numbers on the number line, and that's it, they're done. They don't show any work. As a matter of fact, they don't expect that they should have to show any work. What work is there to show with this? But there's actually plenty, and here's what I mean about this. Now I want you to look at these 4 numbers that we've been asked to put on the number line. I'll read them to you, but we have 0.15, which we actually read as 15 hundredths. Of course, this is the tenths and this is the hundredths. We have 8 tenths, which you'll notice the first number was a decimal, the second number was a fraction. This third number here, which is a combination of a whole number and a fraction, of course we know that as a mixed number. Okay, so 2 and 1/4 and 1.6. What makes this such a difficult problem? And I guess I'm not saying it's difficult, but what makes this such a highly missed problem is the fact that all 4 of these numbers are written in different formats. Would this be a different problem? Would this have been easier if I had given you all of these numbers written as decimals? All fractions? All mixed numbers? And the answer to that is most likely yes. So our ambition will be to actually change these so that they are in the same format. And the most common way I find most of the time is to change anything that's a fraction into a decimal. Because without a doubt in my mind, I think that everybody, parents here included, okay, could compare 0.15 to 1.6, and this is due to the fact that, we all understand money. So here's what we'll do. For the time being, we'll turn our emphasis to these 2 numbers, 8 tenths and 2 and 1/4. Now the neat thing about this is, much of the time, there are certain fractions that we should have probably memorized as decimals. For example, 1/2. Well, that's 0.50. How about 1/3? Well, yeah, 0.333333333. And 1/4, 0.25. Okay, so we get used to these things like 1/5, 0.20. 1/6, 0.1666666. And using this information, it makes certain fractions like 8 tenths easier to convert into a decimal. Now, I'm not saying that 8 tenths is the easiest fraction to convert, but I do know 1/4 off the top of my head. What would that be? Right, 0.25. So I look at this and I say 2 and 1/4. Well, hey, another way that I can write this is 2.25. Now we've actually taken one of these numbers and converted it. It's not that it's a different number, it just looks different. So it's like its nickname. Okay? Now what can we do with 8 tenths? Well, there are 2 things we can do. Of course, some people looking at this fraction immediately realize that the numerator and the denominator are both even. Well, what common factor do they share then? What number divides into both evenly? Or you might ask, what number could you multiply to get both of those? And the answer to that is 2, because they're both even. So if I were to take both of these and divide them by 2, I would notice immediately that 2 goes into 8 4 times, and 2 goes into 10 5 times. Now, using this benchmark knowledge that we had stated we probably are pretty darn good at, I know that 1/5 is equal to 0.20. Think about $1. How much money is 1/5 of $1? It's 20 cents. Now, if I have 4 of those fifths, I could take 20 cents times 4, which would produce 80 cents. Now, let's say I don't necessarily know this off the top of my head. Let's look at the original fraction to begin with. 8/10. Now, how can I write 8/10 as a decimal? Simple. You do notice that when you write something as a decimal, the place directly to the right of the decimal is known as the tenths spot. And we have how many of these tenths? 8. So I guess my question would be, is this okay to write? And the answer to that is yes. Now, as a general convention in math, we write a 0 in front of that decimal so that people don't miss the fact that there is a decimal there. But this would be 8/10 as a decimal. Now looking at these numbers again, here's what I see. We have 15/100 as a decimal. We have 8/10. We have 2.25. And we have 1.6. Now looking at all of these, you notice the number line goes in ascending order. So we'll start with the smallest here, but I notice that which one doesn't even have a whole number? Well, there are 2 of them. There's 0.15 and 0.8. Now why might I suggest that 0.15 is smaller than 0.8? Well, when I compare the whole number spot, I notice there's a tie, and I skip 1 spot to the right, which is the tenths. And I notice 1/10 is smaller than 8/10. Now this doesn't have to be perfect, but I tell you what, I know that 0.15 is somewhere between 0 and 1, and most definitely less than a half. So I might put it somewhere like here, and label this 0.15. Now I know 0.80, or like 80 cents, it's a little bit less than $1, not a lot. We might put it here, but the important thing is that I'm labeling it also. Okay, next we have, well, 2.25 or 1.6. Well, $1 is less than $2. So after comparing the whole numbers, 1.6 would come next. And you know, the question here is 1.6 bigger or smaller than 1/2? Well, it's bigger than $1.50, so we can put it a little bit further up, say 1.6, and finally we say, well, 2 and 25 cents. Remember, that was the same as 2 and 1/4. So not only is it 2, but it's half of a half. So 2 and 1/4 should rightfully be in this spot. Okay? And that's how we'll address problems of this nature, trying to make everything similar. We keep running with this idea of making everything common, comparing things that are the same, apples to apples. And I'm not talking about the game here. When we look at number 7 here, which asks, write 2 fractions and state which one is larger. Now hold on a second. Unless you write 2 fractions that have a common scale factor, you're going to probably more than likely write 2 fractions that are not equal. So one has to be bigger than the other. So how about I just make 2 fractions up? For example, how's about, 4/5 and 2/3. Now I tell you what, these fractions would be very, very easy to compare if something was true about it. I know first of all that 4/5 and 2/3 are actually very close together, but that they have different size pieces that they're talking about. This is 4 out of 5, but this is 2 out of 3. Now we could draw a picture, we could, and I'm pretty good at drawing, but I'm not that good. Here's what I mean. If these had been the same size pieces to begin with, you could compare them fairly easily. So my question to you is, what would be a common denominator we could choose between 5 and 3? You can pause the video now if you like to take a second to answer this.